Question number 22, another from rotational motion and more precisely moment of inertia. A bit of variation has been given but not very tough. A disk of mass m, radius r has been given, and this is the surface mass density which depends on the radius, the distance from the center. We need to calculate the moment of inertia about an axis going through its center of mass and perpendicular to the plane. So this is the disk, the axis is this. If that was a uniform disk, it would have been mr square by 2, but this time it's a non-uniform one. But yes, the variation is there, which is a symmetric one, and you know, the way how we calculate is the ring of increasing radius. Okay, so the first thing, see, if I calculate the moment of inertia, consider an elementary ring. The mass of that elementary ring would be k r square into 2 pi r dr. That's fine. The surface mass density into smaller area multiplied by r square will give the moment of inertia of an elementary ring of radius r. And you integrate it, limit from 0 to capital R, that's going to give you the required moment of inertia. However, you could see that the option does not have anything like k. The option has variable like m, which is the mass. And that's not a tough deal either. All I require is that from the given density, I'll calculate mass, so I'll relate k and m. And that is something like this. The total mass is going to be sigma, which is k r square into 2 pi r dr. The limit will be 0 to capital R. There you go. The second relation allows you to relate k and m. The first relation will give you the value of moment of inertia. Do it. Enjoy a bit of calculation. Option number 4 would be the correct option. Time to move to the next question. The next one from thermodynamics. A cylinder with fixed capacity. Okay, mind that word fixed. That means the volume is constant. Of 67.2 liters contains helium gas at STP. Now you see, having done so many different numerical variety in chemistry, this one gives you a straightforward hint. STP, the volume is 67.2 liter, so obviously the number of moles would be 3, 22.4 multiplied by 3, right? You need to calculate the heat to raise the temperature by 20 degrees centigrade. And the process is, you see, isochoric, constant volume, the fixed capacity. A bit of deviated one, but yes, ultimately easily understandable. So here what you do is that you require the heat and you do Q equals to N CV delta T. Well, helium, monoatomic, so this would be 3R by 2. Put the value, get option number 4 as the correct one. Fine then, let's move to question number 24. Question number 24, moving charges and magnetism. Motion of charged particle in a magnetic field. Circular path. I think now you got the hint, and very straightforward. So there are proton, electron, helium, all having same kinetic energy, and they go into the magnetic field to make a circular orbit. So look at the clue point, all have the same kinetic energy. We need to find the relationship of their radii, which is there. And now it comes, R is root of 2km divided by BQ. And see, kinetic energy for all is same, so this will effectively be root m upon q. And that's quite simple. For proton, if I call the mass is m, for alpha particle, you see, the helium nucleus, that will be 4m. And for the electron, that will be m upon 1837. The charge for proton and electron, both will be E if I talk about the magnitude. And for helium, that will be 2E. So you just put those values and compare the radii. That's a straightforward question. Option number 3 is going to be the correct one. Let's go to question number 25.